Okay, so if we look at railroads around the world, you sort of get it tells a very interesting story. Railroads have historically been the means, certainly in the last 250 years, it's been the means to open up unexplored territory and to take land or parts of a country that are not useful and to grow it. In the middle of in the 1860s, for example, 1870s, the United States used the railroads to open up the West, to basically build the West, the building of the Transcontinental Railroad. In this century, and I got to see part of that, China used the railroads dramatically in the period between the 1960s and the 1990s to open up their country and to make it integral. I've been consulting actively in China since the 80s, and I watched China grow. And I've been sort of like going to China every decade from the 80s on. I watched China go from an underdeveloped steam-driven railway system to one of the best railway systems in the world. In the 1980s, for example, China was the largest recipient of World Bank money for railway development in the world, and they used it to good stead. So why am I saying this to you? Because I think this is part of things that I see happening with Israel and the growth of the railways. And hopefully, if they end up building the Eilat line, which has already really been designed, and the route selected, that will also further development of the southern part of Israel, the Negev, particularly the southern Negev. You can see the extensive development in Europe. You can see the United States and Canada, India, Eastern China, Japan, and you can see the vast undeveloped large portions of the world here. Africa is is a classical case of this. If you notice, the African railroads actually, for the most part, go from the port inland and back. Why? Because this is a vestige of the old colonization, where the European colonial powers used to take raw materials out of their African colonies and ship them back to Europe, and then ship goods back to their colonies and ship them inbound. The only exception to that really is South Africa, which has the largest developed railway system in the world, in Africa. By the way, some of those Western mining railways I mentioned in Australia are right over there, out in beautiful scenic Port Hedland, Australia, where nobody but people like me go to. Trans-Siberian Railroad opened up Siberia big time. It was, again, it's the largest single end-to-end railway in the world, larger than any of the coast-to-coast railway networks in the United States, for example, or in Canada. So let's talk a little bit about worldwide railway standards. The world sort of divided into 2.5 or 3 blocks, if you want to so to speak. The largest set of standards in the world, or the largest group of railways that follow a single set of standards of the world, is the International Union of Railways, UIC, Union International Chemin de Fer. That's why it's UIC. It's the French version, Union International Chemin de Fer. It has, last I checked, over 500 member railways, including Israel Railways, and it dominates Europe, Africa, and parts of Asia. It's again, its standard is a maximum of 22.5 metric ton axle loads. Again, remember the axle load designation. This is how we talk about railway loading in the industry. This is the standard way of referring to it. And it has a maximum allowable axle load of 25 metric tons. And recently, they've been forced to allow exceptions because, among other reasons, the Swedish railway system up in northern Sweden, going from the iron ore mine in Kiruna to the Norwegian port of Narvik, forced them to go up to allow exceptions up to 30 tons. This is very much the exception rather than the rule. So you're looking at 25.5 metric ton axle load standards. You're also looking at relatively low train weights and relatively short train lengths. So you're looking at train lengths of the order of 3/4 of a kilometer, 750 meters. You're looking at about 4,000 ton trains on level routes and 1,400 tons on severe grades. So what I mean by a grade is a rise. We'll talk about that in a few moments, determined in either in percent or in mils. The other big dominant one follows what's called the Association of American Railroad Standards, but it's broader than that. This includes the whole heavy haul world. So heavy haul railway lines include a lot of Australia, all of North America, large segments of South America. Actually, several parts of South Africa follow the heavy haul line operations as well, and China. The heavy haul world has a 36-ton axle load maximum. In North America, 33 metric tons is the free interchange limit, which means wagons can travel freely between different railways in Canada and the US and Mexico if they're 33 metric ton axle loads or less. But they do have exceptions up to about 41 metric tons. Now, this is where we see the long, heavy trains I showed you those nice, pretty pictures of. Trains are about 3 to 5 kilometers in length, 12,000 metric tons or more in weight. As I mentioned, the heaviest train was about 100,000 tons. This says BHP Australia, but I know South Africa also had hooked up some trains together to make a 99,000 ton train as well. So you're looking at about 20 kilometers or so for a train that size in rough terms. I say 2.5, 3, because the Russian and for many years the East European bloc, or certainly right now what we call the CIS, the Commonwealth of Independent States, follow the Russian standards, which sort of are halfway between UIC and AAR. But having said that, when it comes to things like train weight and things like that, they tend to follow to go closer to the heavy haul standards. And in fact, the Russian railways are part of the International Heavy Haul Association. So why in the world do we want to have heavy axle loads? Why do we want to have axle loads that go up to 39 or 41 metric tons. Doesn't that cause a significant amount of damage to the track structure? Doesn't that increase the risk of failure? Doesn't that increase the risk of fracturing the rail, breaking a fastener, breaking a wheel or an axle? The answer is yes. But the other part of it is the efficiency of operations. So let me introduce a couple of interesting concepts to you that I want you to make sure you understand. When we talk about the weight of a wagon, particularly a freight wagon, we have the gross weight of the on rail, which is the total weight of the wagon. Also, which for a heavy axle load wagon could be of the order of about 130 tons gross weight on rail. And that weight is divided between the weight of the wagon empty and the weight of the commodity that it carries. So a 130-ton wagon, the wagon itself will weigh about 27 tons, and the commodity it carries weighs a little bit over 100 tons. So it's carrying about 3.5 to 4 times the empty weight of the wagon. Now, when you're dealing with freight, remember, people are paying you to carry the commodity. They're not paying you to carry the empty wagon. So if the wagon represents 25 to 30% of the weight of the train, then if you have a 12,000 metric ton train, then 70 to 75% of that weight is commodity that people are carrying you for. If you look at a UIC freight wagon, you're looking at about 90 tons of commodity. And because of the UIC standards and design, they're actually a little bit heavier than an AAR wagon. So the wagon itself weighs about 30 tons. And so it carries about 60 tons of commodity. So it carries about twice as much commodity as the empty weight of the car. By the way, we refer to that as net to tear. Net being how much commodity we carry, and tear, T-A-R-E, refers to the weight of the wagon. So in this particular case, fully a third of the wagon of the train is tied up by the empty weight of the wagon itself. So the wagons are less efficient. And so as a rule, those rail systems that are looking to optimize the efficiency of their freight tend to follow the AAR standards. Those railroads that are looking really to optimize the efficiency of their passenger operations and the freight is an afterthought, then you'll see more in the UIC standards. And that's very common in Europe, where freight is not that aggressively shipped by rail. In fact, more freight is shipped in Europe by barge than it is by rail. Places where freight is very important in terms of the shipping, like North America, China, Russia, Australia, India, South Africa, you'll tend to see more of the heavier axle load standards. Okay. By the way, let's talk about these are also the standards group. It used to be UIC. Now, in recent years, the European Union issues its own standards, which have superseded some of the UIC standards. But the European Union only deals with the European railroads. For example, Israel is not a part of the European Union, but Israel is a part of the UIC. So the UIC standards, which cover both vehicle and track and operations, are the standards that govern this type of UIC railway operations. In the AAR heavy haul world, the AAR, which is the Association of American Railroads, these standards cover wagons. And if you want the track standards that go with it, the track standards are the American Railway Engineering and Maintenance Way Association, or AREMA. AAR actually doesn't issue track standards, but AREMA does. So AREMA is your recommended practice for standards. And the AREMA standards are available, just like the UICs are available for purchase. On the metro side, so the UIC and the AAR standards deal with both passenger and freight. But it deals with interurban passenger. On the metro side, they usually don't get into metros. So in the US and North America, the American Public Transit Association, or APTA, is the major transit standard organization. In the European side, or the international side, International Association of Public Transport, or UITP. UITP being the French version of the International Association of Public Transport. Now, one of the areas that we find being a major engineering area that impact railroads very, very extensively and very aggressively is the gauge of the track. So gauge, as probably, I hope all of you know, a lot of this stuff I hope is you already know the basics. But the gauge is the distance between two rails as measured, between the inside face and the inside face. So it corresponds to where the wagon wheels go. Your railway wagon wheels will run on the inside face to inside face. So gauge is your distance between inside face and inside face, measured a defined distance between below the top of the railhead. Now, the world is divided between three different types of gauges. Standard gauge, well, actually, there are multiple gauges, but three categories of gauges. Standard gauge, wide gauge, and narrow gauge. Standard gauge, which is what Israel uses and the United States uses and most of Europe uses, you can see from this blue color, the standard gauge is 1,435 millimeters. 4 feet, 8.5 inches, 56.5 inches. That is historically, that dates back to the old British steam engines. And that some people argue that it actually dates back to the old Roman carts. They used to be run in England before, because when they laid down the track for the steam engines, they followed the old grooves in the road caused by the old Roman carts. But in any case, most countries in the world, certainly the major countries in the world, US, Europe, China, Australia, North Africa, Middle East, they follow the standard gauge. Wide gauge is literally what it says. The gauge is wider than standard. The two most prominent wide gauge railways in the world are Russia and Spain. So why does Russia have wide gauge? Well, it's not just because the Russians want to be different. It's just, but the reason for wide gauge in Russia is pure military. Russia's been the subject of invasion for centuries. And around the time of the Napoleonic invasion, Russians decided that they didn't want to allow armies to just take a railroad and go into their country. So the simple expedient was to have a wide gauge. So if you're coming along on standard gauge, and all of a sudden you run into a wide gauge track, your wagons can't simply go across. They'll fall in and derail. So Russia built their wide gauge railway as a defensive measure. And by the way, in World War II, when Hitler invaded Russia, the benefits of that strategy actually paid off. Spain also historically has had wide gauge, and I think part of that was also military concern about invasion from France. But interestingly enough, in the modern era, Spain, which has the most high-speed rail lines in Europe, all their high-speed lanes are standard gauge. Now, for many years, Spain tried to maintain dual gauge, standard gauge and non-standard gauge, which is a very difficult system to maintain. The track itself, it's not so hard because you can just simply put 3 rails down there. But the switches are a disaster. So trying to put a switch with 3 rails going across is a design nightmare and a maintenance nightmare. So all of the Spanish high-speed rails are now standard gauge. And so they allow for easy access now into Spain. In fact, the trains just don't even stop at the border. They just keep going across. And you see that network there. The other class of gauge that you see are the narrow gauge railways, of which Southern Africa, or Africa in general, actually, is the biggest example of. But we have narrow gauge in Southeast Asia. We have narrow gauge in South America. A lot of Brazil is narrow gauge. And again, a lot of the reasons for building narrow gauge is cost. It's just cheaper to build a narrow gauge railway than it is to build a standard gauge railway. Okay, just to give you an idea of the relative amount of passenger and freight traffic you see by different countries. Started off with freight.
Alan, can I have a question?
Yes.
I don't understand why it's cheaper to have a narrow gauge.
Because your sleeper and your road bed are smaller. You have to build a smaller.
It's not much cheaper.
Well,
actually, you need all the system, and it doesn't seem that it's much cheaper. All the systems, all the turner, you need all exactly the same system.
Yeah, but when you have narrow gauge, everything is reduced in scale. So your sleepers are cheaper, for example, because your sleepers are now shorter. So they're physically cheaper because they're smaller. You use less ballast just because you have physically smaller distance between one shoulder and the other.
I understand.
What about the speed?
I will tell you that nowadays very few people build a narrow gauge in modern times because the difference is not worth it. But remember, a lot of the railroads, for example, a lot of the narrow gauge railroads in Africa and South America were built in the 19th century. And they wanted to do things as cheaply as possible.
Okay, thank you.
Yeah. In fact, the problem right now is that a lot of narrow gauge railroads want to build themselves into standard gauge railroads. And we're seeing, for example, we're seeing that in Africa. We're seeing that a lot in Southeast Asia with the Southeast Asian railroads, particularly if they want to connect to China. And India also has a bunch of narrow gauge railways, even though they're more wide gauge than narrow gauge. India is a funny country. India has standard gauge, narrow gauge, and wide gauge. But everything India is building now, for example, is standard gauge. Everything Africa is building right now is standard gauge, except in Southern Africa and South Africa, which still retains the South African gauge.
What about the speed?
Slower. Absolutely. With narrow gauge, you're less stable. You know, from a dynamics point of view, because your rails are closer together, your wheels are closer together, you have you're less stable. So your speeds are slower. And anybody right now, anybody building anything high speed is building it to standard gauge. No, but there are a huge number of disadvantages to narrow gauge from an engineering point of view. But historically, you have maybe close to a third of the world was built with narrow gauge, and they physically don't have the resources to just change it in one fell swoop. So that becomes the reality. The Chinese, by the way, are very good. They go into Africa, and they offer to upgrade the railways of the African countries as part of their diplomacy. And then they send a whole bunch of Chinese labor to do the work, which is pretty cheap. And so you see a lot. You're seeing some of that as well. Okay, so if we talk a little bit about just to give you an idea of freight traffic. So let me introduce another term for you, which is ton kilometer. And its cousin is passenger kilometer. Now, you may have run into these terms before, but a ton kilometer is moving 1 ton of goods 1 kilometer, and a passenger kilometer is moving 1 passenger 1 kilometer. So if I had, so let's say I have an Israeli freight train that's moving, that has 2,000 tons worth of goods on it. Or actually weighs 2,000 tons, because you usually deal with gross kilometers. So if I have 2,000 ton train and it goes 100 kilometers, then I have 200,000 ton kilometers that I've moved. So you can see the scale here is in billion tons kilometers. I haven't quite upgraded this because the numbers, the numbers have changed a little bit, but not grossly. What's interesting to see here is the U.S. has the largest and moves the largest amount of freight in the world of any country in the world, 2.7 trillion ton kilometers. China is number 2 at 2.3 trillion. Russia is roughly comparable with China at 2.3 trillion. India is at 66. Canada is at 352. Brazil's at 267. The European Union as a whole is about 261. I actually ran into this when I was part of a UIC committee dealing with safety, where my first meeting, everybody sort of said, why is an American here? You guys have a horrible safety record. Look at all your accidents. And it turns out we had all the reasons we had 10 times the amount of accidents the Europeans had is we ran 10 times the amount of traffic. And when you looked at your traffic per accidents per ton kilometer, per million ton kilometers, the rates were about the same. If you look at modal share, which is an interesting statistic, which is the percent of all freight moved by rail, Russia has the size percentage, which is about 65% of all goods are moved by train. Latvia, you can argue, is going to be similar to Russia. China is just under 60%. And then you start going into places like Switzerland, which is landlocked, 46%, US 42%, and then decreasing accordingly. If you look at ton kilometers per capita, so ton kilometers per capita means per person. So you take the total number of ton kilometers, say in the United States, 2.7 trillion, multiplied by the amount of people, which in the United States would be about 330 million, and you get the ton kilometer per capita. You can see Russia is up at about 12.6 thousand ton kilometers per person. Canada, interestingly, which doesn't have a high population but moves a significant portion of their freight by rail, is about 10,000. U.S. is about 9,000. China is down at about 2,000. That's only because you're dividing it by 1.5 billion. So China, for example, has 5 times the amount of people the U.S. and moves a little bit less freight. So the fact that it will be roughly about 1/4 of the number of the U.S. makes sense. European Union is about 782, again, because they move a lot of goods by barge. Now we look at passenger kilometers, the numbers change a little bit. The largest mover of passengers, as measured by passenger kilometers, is India. 1.2 trillion passenger kilometers. China is number 2 at about 800 million. That number, I think, has gone up significantly. I need to update the slide, but you get the point. Europe moves a significantly number of passenger kilometers. So Europe is comparable to China. Russia is significantly less because the Russian railway system, while carrying a lot of passengers, aren't carrying anywhere near the percentage of the total people who move because of the distances. And U.S. is way down in the bottom here, with most of the European and Asian countries above it. There's the same, slide duplicate, so I didn't notice that. Railway passenger market share. Interestingly enough, only Russia has the dominant proportion of passengers moving by train. China is about 35%. Japan's about 25%. Europe's about 10%. US is less than 1%.
Can you explain again?
What?
The last, what is passenger market share? Sorry.
What percentage of all the people who travel, what percentage travels by train? So in Russia, 3 out of every 4 people take the train if they're going somewhere. But they're going short distances for the most part. China, 1 out of 3, Japan, 1 out of 4, Europe, 1 out of 10. Okay. The last couple of slides I want to hit before I end the introduction to railway systems is I want to talk a little bit about how railroads are made up and how they're functioning, because that is actually changing in the world. And what's interesting is the way railroads operate and the railways functions. We're seeing a lot of changing in the world these days, a lot of rethinking about how railroads should work. So to start off with, and we're going to see this a fair bit, the 3 major elements of any railway system are the operation system, the infrastructure, and the rolling stock. Now, we're going to spend most of this course is going to be on infrastructure, but you have to understand where infrastructure fits within the railway system, okay? Probably the most, you can argue the most important element of the railway system is operations, also called transportation. That's the people who move the train, whether it's passenger and freight. That's the drivers. That's the dispatchers. That's the people the schedulers. That's the people who run the yards. That's the people who run the stations. These are all part of the operations or transportation part of the railway system. And very often, the top operating executive in a railroad, the number one operating person in the railroad, usually has the engineering and the mechanical people reporting to him as well, because the operations are considered to be the dominant mode, whether it's passenger or freight. The infrastructure deals with the track, with the buildings and bridges, with the power, with the stations, with the signals and communications, anything that's fixed. So Israel's railways, for example, has all of these. In fact, any rail system in Israel, be it the railway or a metro, has all of these. You have the track, which some argue is the largest single cost item in the infrastructure, and usually is, but not always. You have buildings and bridges, which tends to be relatively small, unless you have a line, for example, such as the Jerusalem high-speed line, which has a large amount of bridges and buildings, particularly bridges, and usually tunnels fall into this category as well. I should put tunnels in here as well. Power, you're starting to see that happening in Israel now. So this is whether it's overhead catenary, as you see in Israel, or third rail power, as you see in most metros in the world. By the way, that's another divider between a heavy metro rail system and a light rail transit system, is the heavy metro system will use third rail power. So there will be, in the track itself, there will be a third rail, which is the power rail. And that's where the vehicles, the metro vehicles, draw their power from. And then that power is returned to the running rail to ground. Light rail metros operate similarly to passenger metros, as you see in Israel, where you're drawing power from your overhead catenary. Stations, of course. Yards are often included here, even though yards are usually included on the track. And then signals and communications, which includes both track signals, positive train control, ERTMS, any of the signals and communication systems.
Alan, yards, you mean a depot? Yard.
Okay,
yard?
so a yard is a freight depot.
Freight depot, okay.
Where you have a lot of tracks to build your trains up, to send them to different destinations. Also, where you bring your freight trains in to inspect the trains. By the way, this goes back to the terminology. Please, if I use a term that you're not familiar with, stop me just like you did just now, because very often, depending on whose terminology I use, you may or may not understand it. So I will try to remember to explain it, but as you can see, I don't always remember. So please don't hesitate to stop me. The third element of the rail system is the rolling stock. So the rolling stock includes motive power, which are generally locomotives, be they electric or diesel, passenger coaches, passenger cars, freight cars, which are also called freight wagons, MU equipment, self-propelled equipment. So for example, metros tend to be our self-propelled equipment. Look at Jerusalem. There's no separate locomotive. The metro vehicles has the traction motors are in the bogies of the passenger coaches. Several of the high-speed rail systems that you see in Europe, like the TGV, the newer generation TGV, have locomotives and also have traction motors underneath the passenger wagons, over the passenger coaches. So you see a combination of that.
What is the abbreviation of MU?
Multiple unit. Okay, so if you look at the traditional railroad makeup, and I will tell you Israel Railroad falls into this category right now. You have the CEO, and above, well, first of all, you have a board of directors, and you have a CEO, and you have you have a chairman of board who's usually separate from the CEO or together, however you do it. Then you have your commercial officers, where if you're, I don't care whether you're a passenger or a freight railway, somebody's involved with sales, somebody's involved in marketing. That's the whole commercial side. You have your financial people who do all the necessary financial stuff. You have your various law departments and human HR departments and government affairs and whatever. And then you have the railroad. So you can argue that all these other departments, well, you can say the commercial department's fairly important, because if you don't have somebody to pay for your goods, you don't have passengers, you don't have goods, you need them. But the railroad itself falls under the operating officer. So you usually have a chief operating officer. And the chief operating officer very often comes from the transportation side, but that's where you have your transportation people, your mechanical people, your engineering people, and depending on your organization, and again, in Israel Railways, you do have this, you have your safety people. There's actually a separate safety department in Israel Railways, and they really generally follow under the operating officers, but they're usually separate from and independent from the transportation, mechanical, engineering, and safety. In some railway structures, the safety officer is pulled out of this group and reports directly to the president as a separate safety officer. There are variations in that, but you can see that type of structure frequently. Now, I will tell you, this is the trend this is how railroads in the US are set up. This is how railroads in Israel are set up. This is how traditional railroads in Europe have set up. This is how the Russian railway works. This is how the Chinese railway work, but it's changing. The trend in Europe, and this has been going on since the 1990s, is to separate functions into separate countries. One of the first places to do that was in England. The old classic British Rail, which, by the way, British Rail was a traditional railway, in the 1990s was broken up. And it was divided into a separating operating company, or multiple operating companies, actually. In the UK, they took the entire UK and they broke it up into about 8 or 10 different operating companies, with each operating company having a certain geographical area or a certain set of routes that they were responsible for. There was one big infrastructure company, which in the 1990s was a company called Railtrack, but they went bankrupt because of a major derailment, which we'll talk about when we talk about broken rail derailments. And now there's a company called Network Rail, which is a government corporation, but it's completely independent of and separated from the transportation companies. And then there would be rolling stock was divided up. So the operating companies in the British system would own the passenger coaches or the freight wagons. They would own the locomotives, but they would tend to contract out the maintenance. So all the maintenance was contracted out. So you had an interesting situation. So you had people like Virgin Trains, for example, or the Great Northern. I said there were 8 or 9 different countries in the UK that were just passenger operators. In the UK, they had set the freight operators were separated. So you had the English, Welsh, and Scottish railways. So the Virgin Trains, for example, owned or leased. More likely, they leased because they only had a limited contract. They leased the passenger coaches. They leased the locomotives. Their employees drove the train. Their employees sold the tickets. Their employees set the schedules and timetables. English, Welsh, and Scottish railways likewise owned their freight wagons. They owned their locomotives. But the infrastructure was owned by Network Rail, a completely separate company. The Swedish did the same thing. The Sweden had
how they do the coordination if it's all the different
that's a very good question. That's a very good question. What they did was they moved the dispatching into the infrastructure company. So you understand the dispatching? Dispatching is one who coordinates the trains. So in fact, the infrastructure company in the UK, for example, Network Rail, was responsible for dispatching. And as a result, was there a lot of politics? Yes. In fact, the British system just actually last year came out with a major study wanting to change how the systems. They're still keeping the train operator infrastructure company separation, but they're changing the way the dispatcher is done because they found it was very inefficient. But just the same, it's interesting, that's the trend. The Swedish have done the same. The Swedish have separated all the passenger operations in Sweden are under SJ, which is a Swedish National Passenger Railway. The Swedish freight for a while was under a company called Green Cargo, but they've since allowed other freight countries into there. And the infrastructure was separated out, exactly like the UK, into a government-owned company, which used to be called Banverket, but the name was changed a couple of years ago to Trafikverket. So Trafikverket is the infrastructure company in Sweden. And these are separate entities. They coordinate with each other, but they have separate people. What's interesting is we're starting to see some of that separation moving into France and Germany. So, for example, Germany has been looking into separating out their freight operation from their passenger operation. So they have DB Cargo. So DB Cargo right now is the freight arm of DB. And it's separate, and it's sort of almost a separate company. The worst case, as I said, was the UK. I was wrong. There were 28 different operators. I didn't quite remember. Okay, so
can I have a question, please?
Yes.
I see a lot of disadvantages in this, like
yes.
In coordination and
Absolutely.
Responsibility. But
I agree.
What are the advantages? Still, they do it because of some reason.
The advantages were they wanted in the 1990s, there was a major push to privatize as much as possible government companies. And so British Railway was a classic government company. And so they wanted the plan to privatize it was to break the operators up regionally. So for example, you can see the East Midland trains operate the Midlands, Liverpool, Nottingham, York, Leeds, Sheffield. It's an area actually I spent a lot of time in. Arriva trains, Great Western trains, each of them had different geographic locations. but they didn't want to separate out the track because there were a lot of efficiencies in having all your track being performed by the same entities. So they formed a separate track company. Now, when they first privatized it in 1990, they actually privatized the infrastructure company. Railtrack was spun off as a for-profit private infrastructure company. And they kept that way for about 7-8 years until there was a major derailment in the UK, which I will actually talk about when we talk about broken rail. There was a major broken rail derailment called the Hatfield derailment. And the consequences of that derailment was such that there were about 3 billion with a B pounds worth of penalties imposed on Railtrack. And Railtrack went bankrupt, literally went bankrupt as a private company. Now, you couldn't have the infrastructure company of the entire railroad being bankrupt. You know, obviously that doesn't work. So they went ahead and they formed a network rail at that point in time out of the bankrupt Railtrack. And that's been working to date. But is it inefficient? I think so. Now, having said that, in the United States, okay, the big freight railroads all have the classical structure. The big freight railroads all have this structure. But Amtrak has this structure only in some part of the country. So, for example, Amtrak owns the track only in the Northeast corridor between Washington and Boston.
What is Amtrak?
Amtrak is the big passenger operator in the United States. The big national passenger operator in the United States only owns track between Washington, D.C. and Boston. Every other train that it operates runs on somebody else's track. And there are laws that govern it, and you know, there are issues in that. But one of the reasons there, for example, is that the freight railroads don't want the passenger operations. They lose money. They're not profitable. So the freight railroads don't even want the passenger operations. So they're perfectly happy letting, and what happens was, and this is the same system as they use in the UK and Sweden, a train. So let's say Virgin Trains runs its trains on Network Rail track. They pay for every kilometer of track they operate. So if you know, they pay per kilometer. You know, it's almost like a toll per mile. It's equivalent to a highway toll per mile. They're paying an infrastructure charge on a kilometer basis. And
but who does the design for new tracks?
The new design, new tracks will be done by the infrastructure operator. So Network Rail would design all new track.
But the question, if by experience for 30 years they understood it was wrong, or maybe not, is it any way back to central
no,
coordination?
No. But the rules, like I said, there was just a very recent study that was just released last year. It was an interesting study. It's a brand new study.
Yeah, very interesting.
And the new study basically says they need to rethink the rules and the relationships between the operators and the infrastructure. They're not talking about combining them, but they want to rethink the relationships because the relationships are not that efficient. And the other thing that happened, by the way, is coronavirus. Because these were all for-profit companies, you know what happened to railways and for coronavirus happened to Israel railways. Passenger rail went way down. People started working by internet. Nobody took the trains anymore. Railroad revenues plummeted. Amtrak lost 90% of its ridership during the peak of coronavirus. The European Union railways, same thing. 70-80% of the passengers disappeared. And so there was a major financial burden on that. For a government-owned company, okay, it's handled by a government infusion of cash. Not happy with it, but it's doable. For a private company, you can't do that. And so this is something else that came into this whole picture. I see the same problems you do. I happen to like the American model, by the way, where the railroads are private. But the reason railroads can be private, at least the bulk of the railroads are private. Of the 300,000 kilometers of railroad in the United States, 290,000 of it is privately owned. But the only reason it works is because they happen to be very profitable. American freight railroads, as I said, they're very profitable. To show you how profitable it was, Warren Buffett bought the Burlington Northern Railroad. Everybody's heard of Warren Buffett, I assume. Warren Buffett thought it was such a great investment, he bought the Burlington Northern Railroad. And not only did he buy it for $25 billion, last I checked, it was worth over $50 billion. So he made a lot of money in the process. But as I said, the issue is when you're a government-owned railway and you're losing money. Like the British rail was a money sink, was losing money. The Swedish railway system was losing money. The SNCF loses money. The Deutsche Bahn, the passenger division of Deutsche Bahn, loses money. You see, there's a point in which you say, do I look at a better way to reduce my bleeding, so to speak? And so the problem is it's not as efficient from an operations point of view, but privatization has some financial benefits. And that's why the British are not ready to go back to a completely government-owned British rail anymore. That's not on the table because it costs so much money to operate it. And that's why, it's been delayed, but that's why the SNCF, the French and the Germans are still looking at the separation model. Okay. My original plan was to try to do a break every hour, 15 minutes, because I thought 4 hours was too long to go with only one break or no breaks. So it's